Number 14. If the acceleration of an object is 0, does this mean that no forces are acting on it? When we read through the choices, only C is the possible choice because that's been our entire unit. Non-accelerating objects with forces acting on them. So, for A, let's go ahead and solve that now. We want a free body diagram of this system for number 15. So we've got the normal, we've got the weight, we've got F1, we've got F2, and finally we've got the friction force acting backwards. Now let's assume we're pulling with a maximum force. Just immediately before the object moves, we went under the force of friction and the coefficient of friction. So let's go ahead and solve those now. The way we do that is, I'm just going to use the area for part A for this. Let's set up our equation. So we've got the normal equals the weight. We've got F1 balancing F2 and the friction. And now we can go ahead and plug in some numbers. So I know that the normal force equals m times g, and that's going to give me 98 newtons. And then for F1 and F2 equation, this guy here, I've got 30 equals F2, which is 10 plus friction. So I have a friction of 20 newtons. So that actually ends up solving the friction force. Now what I can do is I can use friction as fun to get the coefficient. So I have 20 equals mu times 98. And I'm going to get mu equal to, I'm going to round here and say it's about 0.2. Now, let's assume that we get the block moving and friction acting on it needed to keep it moving at constant velocity is 10. F2 stays at 10. What does F1 equal? Well, when we look at this equation from before, we have F1 equals F2 plus F. So we're going to end up getting F1 equals 10 plus 10, which is 20 newtons. Similarly, when we want to get the coefficient of friction, we're going to end up getting that friction, which is 10, equals mu times 98. And so we're going to end up getting mu equals a little bit over 0.1. So that's the fourth page of the exam. We'll continue.